Hello everyone, this is Katish here. In this video, I'm going to go through the AQA Combined Science Trilogy, Physics Paper 2 Higher Tier from 2023. This Paper 2 is tested on four main topics: forces, waves, electromagnetism. Question number 1 is on waves, or electromagnetic waves specifically. Question 1, the sun emits a continuous spectrum of electromagnetic waves. Figure 1 shows some of the groups of waves in the electromagnetic spectrum. Name groups A, B, C, and in figure 1. So here we've got A, B, then infrared, visible light, ultraviolet, C, and gamma. So A is going to be radio waves, B is going to be microwaves, and C is going to be X-rays. So A is radio waves, B is microwave, and C is X-rays. Question 1.2. Give one similarity and one difference between the properties of ultraviolet waves and gamma rays. So ultraviolet and gamma, they're both electromagnetic, which means they share certain similarities, like they have the same speed, which is the speed of light. They both transfer energy because all waves transfer energy. So they have the same speed in a vacuum, they both transfer energy, and they're both transverse waves. All electromagnetic waves are transverse waves. The difference is that gamma has a higher frequency. So if you look at this diagram, gamma has the highest frequency, and the lowest wavelength. Here it has the highest wavelength and lowest frequency. So as you go from radio waves to gamma, this direction, the frequency increases and the wavelength decreases. Let me get rid of that line. So the difference is gamma has a higher frequency and gamma has a shorter wavelength. You could also say gamma is more ionizing and gamma is more penetrating as well. Remember, of the three waves, ultraviolet, gamma, and X-rays are ionizing, and gamma is the most ionizing out of the three. As a separate note, you could also say they both travel through a vacuum, or they're both ionizing, or both can harm living tissue, or they can both be used for medical treatment or imaging. And you could say gamma has more energy as well. Figure 2 shows white lights split into a spectrum of different colors by a glass prism. Light changes direction when it enters the glass prism. What name is given to this process? When light is changing direction, we call it refraction. Use the physics equation sheet to answer questions 1.4 and 1.5. Write down the equation that links frequency f, wavelength lambda, and the wave speed v. So wave speed is equal to the frequency multiplied by the wavelength, or you could write the simple equation v equals f lambda. The wave in the middle of the spectrum has a wavelength of 5 times 10 to the power minus 7 meters and a wave speed of 3 times 10 to the power 8 meters per second. Calculate the frequency. So V is f lambda. So wave speed is 3 times 10 to the power 8 equals frequency multiplied by the wavelength, which is 5 times 10 to the power minus 7. So frequency is 3 times 10 to the power 8 divided by 5 times 10 to the power minus 7. That gives me a frequency of 6 times 10 to the power 14 hertz. So that's 6 times 10 to the power 14. That brings us to the end of question number 1. I will see you in question number